Okay, that's the rules lawyering. Let's get back to the fun. Just like we've seen on the picture, the fact that these limits go to infinity is shown on the graph of the function. So I'm going to go back to my graph once again. Here's my y equals 1 on x squared. And I can just see that limit. I can't see the limit. The limit exists off the top of my computer screen. But I can observe that behavior. So this is going to be the same on any limit which goes to infinity. These are the same things that I've been calling infinite discontinuities when we were talking about continuous functions. So what's going to happen is that there's going to be a vertical line. The formula of that line is going to be x equals a. Which a is this? This is the a in the limit. So this vertical line is a shape that the graph of f approaches. Let me plot this out. In red is my 1 divided by x squared function. The problem coordinate, the value of a, is 0. As x approaches 0, my function goes to infinity. So that tells me that there's a vertical line, formula x equals 0, and here I have it highlighted in blue. My function is red is going to approach that vertical blue line. And I'm going to call that an asymptote. I expect you've probably seen that in a previous class, but that is our definition. If limit of f of x as x approaches a is infinity, then the vertical line x equals a is the asymptote of that graph. Careful, only one s. So this can happen in lots of different ways. Your textbook writes it as 6 different ways. I put it just down to 3. So like my 1 divided by x squared picture, if the limit on both sides goes to positive infinity or to negative infinity, then we'll have a vertical asymptote at x equals a. You can also have these one-sided limits, right? We've been seeing some piecewise functions with this kind of behavior. So maybe the function only goes to negative infinity, and it only does that on the right side of the graph, but the left side is defined just fine. Well, that's still an asymptote. I guess you could call it a one-sided asymptote, but we're not going to worry about handedness here. As long as any of these conditions are true, as long as any of these limits go to plus or minus infinity, that coordinate, x minus a, that vertical line, that's going to be a vertical asymptote of the graph.